So in precalculus, we learned how to determine graphically when functions are increasing, decreasing, or constant. And so we just want to take a brief moment to review those ideas. So in the box here, I formally defined increasing, decreasing, or constant functions. So I'll leave that here for you to read. What I want to do is kind of informally walk through what we learned in precalculus. So in precalculus, what we identified was that a function is increasing if, as we move from left to right along the input or x-axis, the function is going upwards, or in other words, the function outputs are increasing. And a function could be increasing. In this example, you can see that the function outputs are negative, but we can still be an increasing function if the outputs are negative, as long as the function is moving upwards, as long as we're moving from left to right along the x-axis. So the graphical interpretation that we learned in precalculus was to identify the open interval over which functions were either going up, down, or staying constant. So for this picture, the interpretation would be as we move from left to right, coming from negative infinity up to an input of a. So here's the vertical line x equals a, which tells us that the x coordinate here is a. So if we're moving from negative infinity to a, from left to right on the x-axis, we see that the function is moving upwards. So this means that the function is increasing over that interval. And then as we move from left to right along the x-axis between x equal to a and x equals b, so as we walk across the open interval from a to b, what we want to notice is that the function is moving downwards. It's decreasing. The outputs are getting smaller and smaller, so we have a decreasing function. And then once we get past an input of b, moving along the x-axis towards positive infinity, so on the open interval starting at b and moving towards infinity, we see that the function is now going upwards again. So the function outputs are increasing on this open interval. And these increasing, decreasing, and constant intervals are always going to be defined in terms of open intervals. So in precalculus, what we did is learned how to look at the graph, from the picture of the graph come up with the open intervals, and then by looking at the graph decide whether we had increasing, decreasing, or constant functions. The goal in the next few videos is going to be to identify how to not use graphical interpretation to determine these increasing, decreasing, or constant intervals, but to use the tools of calculus. So just one more review example from precalculus. So here's a function. I see I have vertical lines x equal a and x equal b, so that corresponds to a and b on the x-axis. And I chose those vertical lines because they're really breaking the function up into intervals over which we are increasing, decreasing, or constant. So what we want to notice is that as we move from left to right along the input or x-axis, the function, even though it's negative initially, is moving upwards, so the function is increasing. So I could identify that moving from negative infinity towards a on that open interval, the function, because it's moving upwards, the outputs are getting larger and larger and larger, so the function is increasing. And then between a and b, on the x-axis, as we move from left to right, we can see that the function is neither increasing nor decreasing. The function output is a constant over that interval. So from a to b, we have a constant function. But then once we get past an input of b and move from left to right, the function once again is moving upwards. So from the open interval from b to infinity, we see that the function is again increasing. So again, this is a graphical interpretation of whether a function's increasing, decreasing, or constant. And in precalculus, this is how you did it. You looked at the graph of the function and you utilize the graph of the function to make the decision as to whether on a given open interval the function was increasing, decreasing, or constant. In the next video, we're going to look at how do we use the tools of calculus to make those same decisions, and the tools of calculus will free us from even needing to see the graph of the function to make those decisions.